Okay, at the end of the last video, after talking to you about what confidence intervals are and what kind of situations we were dealing with, I showed you this example problem, and I showed you what the answer looked like, but I didn't say anything about how to get this answer, how this was calculated, how you come up with this. So that's what we're getting into now. There is a formula for confidence intervals that you would use to calculate this from the information given in the problem. And there's also a special graphing calculator function that you can use if you have like a TI-84 graphing calculator. But first, the formula for the confidence interval for the mean looks like this. This is the formula that gave us this interval. Notice it's got something here less than mu less than something else here. The something here is what you calculate to get the first number. The something here is what you calculate to get the second number. And your answer says that mu is somewhere between those two numbers, somewhere in the interval from the first number to the second number. Okay, let's look at the symbols involved here. The X bar stands for the sample mean. That's the average weight of the pink elephants in your sample, those 50 pink elephants that you were actually able to track down and weigh. The sigma here and here stands for the standard deviation. And for now, we're assuming that we do know the population standard deviation. The n here and here under the square root sign stands for the sample size, how big your sample is, how many pink elephants you had in your sample that you managed to track down and weigh. And then this part of the formula here, it's a letter Z with a subscript alpha over 2. That's the Greek letter alpha and then divided by or over 2. So I would pronounce that whole thing as Z sub alpha over 2. And that's a number that depends on the confidence level. So for example, if your confidence level was 95%, you were doing a 95% confidence interval, then the number you would stick into this formula here for Z sub alpha over 2, here and here, would be 1.96. I'll talk a little more about that in just a minute. But notice that both parts of the formula, the part over here and the part over here, are almost exactly identical. It's just that one part has a minus and one part has a plus. So one part has X bar minus something and the other part has X bar plus that very same thing. And that part that gets minused or plussed is the margin of error. So your interval ends up going from your sample mean minus the margin of error to the sample mean plus the margin of error. So it's sometimes reported as X bar plus or minus whatever that margin of error is. Now, let me say something about where the formula comes from, and you don't have to know this to use the formula. So you have my permission to tune this out. If you don't care about where the formula comes from, you can tune out for the next minute or so. But here's where it comes from. It comes from this formula that we were using back in section 6.3 to calculate z-scores from sample means. We had z equals x bar minus mu over sigma divided by the square root of n. Now, if you start with that and do some algebra on that equation, multiply both sides by the denominator of the fraction, by sigma over the square root of n, then get rid of the minus mu by adding plus mu to both sides, then leave the mu by itself over here by subtracting the other part, z times sigma over the square root of n, from both sides. and you end up with mu equals x bar minus z times sigma over the square root of n. And that looks like the confidence interval formula, except that instead of going from x bar minus z sub alpha over 2 times this to x bar plus this, we just have this one equation. So to go from an equation where mu equals something to an interval where mu is between something and something else, the idea is that this z here could be a positive number, could be a negative number, or it could be anywhere in between those two numbers. What are those numbers? Well, they are based on z-scores of the standard normal distribution. In particular, for a 95% confidence interval, we'd ask what z-scores separate the middle 95% of the area under the curve from the other 5% that's in the tails. So this is 95% of the area in the middle here, and then the other 5% is outside that middle range. So there's 2.5% over here and 2.5% over here. And it turns out that the z-scores are negative and positive 1.96. If you make those your dividing points, that separates the middle 95% from the other 2.5% down here and 2.5% up here. And the reason we call this z sub alpha over 2 is that that Greek letter alpha stands for the area, the total area in the tails, which in this case would be 5% or 0.05. So the alpha divided by 2 would be the area in each one of the tails. In this example, that would be 2.5% or 0.025. And then the z sub alpha over 2 would be the z-score that separates the tail from the rest, the part in the middle. Okay, so if you were zoning out, this is the part where you tune back in. Now that I'm done explaining where this formula comes from, let me explain how to use it. So I told you that the z sub alpha over 2 is a number that depends on the confidence level. And for now, I'll just give you this little table here of the most common confidence levels. And for each one of them, here's the number you would put in for z sub alpha over 2. I'll just deal with these values for z sub alpha over 2 that have 2 digits after the decimal point, but sometimes you will see them given out to 3 decimal places. So for a 99% confidence interval, the number you would put into the formula for z sub alpha over 2 would be 2.58, or if you wanted to be a little more precise, you could put in 2.576. But for now, we'll stick with just these 2 decimal place versions. So this little table here gives the number that you plug in for z sub alpha over 2 based on what your confidence level is. Instead of using the formula, if you have a graphing calculator, you can take advantage of its special built-in function. And I will show you how that works in our pink elephant example. So you would press the Stat button and then go over and highlight the word tests. And what we want is number 7 on the list, the one that says Z interval. So to select that, we can just press 7, or we can use the arrow buttons and enter. Now when you do this, you're going to get a little screen that's going to say Z interval at the top, and then it's going to say input data stats. If it's on data, we need to switch it over to stats for a problem like this. For it to be on data, that would be if you had all of your individual data values, like all of your 50 individual weights for all the elephants in your sample, and you wanted your calculator to work with those and do all the calculations from those. But here, It didn't tell us what each individual elephant weighed. It just told us that the sample mean was 9650. So to put that in, we need to go to stats. So highlight the word stats and hit enter. And now we're going to put in 4 numbers. And the order it's in here, the first thing it wants is sigma. So I'm going to put in 110 for sigma. For X bar, I'm going to put in 9650. For N, I'm going to put in 50. That's my sample size. And for C level, well, it's already what I want. It's 0.95. So the confidence level is 95%, but I got to put it in as a decimal, so it's 0.95. And then go down and hit calculate, hit enter, and there's my interval. 9,619.5 to 9,680.5. So if you have a graphing calculator or something like that that can do this for you, you're welcome to use it. In the rest of the examples, I'll be using the formula so you can see how that works and how to calculate it from the formula. So let's do an example using the formula. Find the 99% confidence interval for the population mean if you have a sample of size 49 whose mean is 312 if the population standard deviation is 13. So notice that in this example, X bar, the sample mean, is 312. You have a sample whose mean is 312. Sigma, the population standard deviation, is 13. N, the sample size, is 49. You have a sample of size 49. For a 99% confidence interval, the number we put into the formula for z sub alpha over 2 is 2.58. That was on that little table that I was showing you. And we put it all into the formula, and it looks like this. 312 minus 2.58 times 13 over the square root of 49 is less than mu, is less than 312 plus 2.58 times 13 over the square root of 49. Now let's see what this looks like when we put it into the calculator. We're going to do 2 separate calculations. First, we're going to do 312 minus 2.58 times, and the parentheses aren't really necessary. You can put them in if you want, or you can just put it in as times 13 divided by the square root of 49. And it comes out as 307.20857 and so on. So about 307.2. So that's the first number. That's the left endpoint of our interval. To get the right endpoint, we need to calculate the same thing, only with a plus instead of a minus. And with many calculators, you can just go back and edit what you put in before and change that minus to a plus. So if I go back and leave everything else the same but change this minus to a plus, it gives me an answer of 316.79 something. So that's about 316.8. The other way we could have done this is calculate just the margin of error part, 2.58 times 13 divided by the square root of 49. That comes out to be about 4.8, and then the interval goes from 312 minus 4.8 to 312 plus 4.8. But however we get it, that is 307.2 to 316.8. Okay, I'm going to come back in another video and do another couple examples. Plus, we still need to talk about sample size and how you determine that